right. I'm going to start 1 minute early. I know that live band karaoke is in 20 minutes and we're all keen to get there. But I do want to say thank you for joining my session today. My name is David Flanagan. You may know me from across the internet as Raw Code. I am a staff developer advocate for a company called Pulumi. I spend a substantial amount of my limited free time working on my Raw Code Academy, which is a YouTube channel where I share live streams that feature cloud-native technologies. One of my most popular shows is something called Clustered, where I always say it's the worst idea I ever had. It 100% is. I give people working Kubernetes clusters, and I ask them to break it in 48 hours, and we try and fix them live. So if you really want to get into the deep, bad bits of Kubernetes API server in kubelets, then it's worth checking out. And just as a show of hands, has anyone seen my channel before? All right, cool. And I'm also organizing a Kubernetes conference in my home country. I'm from Glasgow, but I can't bring people to Glasgow because I'd have to give you a map of the streets you can't walk down. But Edinburgh is nice, tourist friendly. So if you're interested in a small community Kubernetes conference, we'd love to have you. Now, I really suck at naming this talk. I've been trying to get people to make one small change to their GitOps pipelines for a number of years now. My first version of this talk was in 2019 at GitOpsCon, or GitOps Days, sorry. And I called it Applying the Law of Demeter to GitOps. Anyone heard of the Law of Demeter? All right, okay, cool. Very obscure rule for building maintainable software with loose coupling. But of course, it means nothing to nobody that hasn't heard of it before. And I realized on my flight here that I've also given it another really shitty name and called it Canonical GitOps, which is not associated with Ubuntu or Canonical in any way. So maybe I think the next time I give it, I'll give it a different name. I'm just not sure what that is yet. What I want to start with is just kind of giving you a quick overview of the Law of Demeter. It's a really good set of rules for building software, and when we apply it to our continuous deployment and delivery pipelines, especially GitOps, I think it unlocks a couple of really cool superpowers. And my mission today is just to try and get you to make this one small change to your GitOps pipelines. So the Law of Demeter is very old, at least as far as technology goes. It was first published in 1989, but had been around for a few years prior as a bit of a research topic at the Northeastern University. The main message and takeaway from the Law of Demeter is that we should build our software in small modules or components that don't leak too much information out to other pieces or other modules within your infrastructure or your software. So we're really trying to build small contained bits of software that we can test, right? This is what we all want from our software. We want software that is going to grow and be maintainable without carrying on too much technical debt. Every time we have loose coupling and we expose those members and our interfaces to other pieces of software, those become part of the contract that we can never break. So we really want to make sure that we understand the Law of Demeter as far as software goes, and more importantly, towards GitOps. The actual title of the paper was very focused on object-oriented programming, and the title was Assuring Good Style for Object-Oriented Programming. That being said, it draws a lot of inspiration from aspect-oriented programming. If you're not sure what that is, there's a really great Wikipedia page on it. Again, it's all about building software where we can augment and enrich the functionality without having to add lots and lots of code to our components and modules. So there's a lot of history here, a lot of good articles online, lots of really good videos. So I would encourage you all to kind of learn more about the Law of Demeter and apply that to your software. And I just want to take a really quick look at traditional CI/CD workflows. Typically, we have some sort of revision control system. We have a CI server. I don't know why we still call it CI, even though it's kind of build these days, but we have that. And then our pipelines and our workflows are generally encoded with all of the environment information. I'm sure at one point we've all had this concept or a button in Bitbucket or GitHub Actions that's deployed to prod and deployed to staging and deployed to QA. And that is a leaky abstraction, especially in a distributed system context where we have microservices. Like, do I need to expose all of my workflows for all of my microservices to understand the environments that I want to deploy to? And there's a lot of toil there. There's a lot of hard work to maintain and keep that, dry and all these other software acronyms that we have. But GitOps did make a big difference here because we inverted the control. We actually removed the knowledge of our environments, or almost removed the knowledge of our environments from our workflows, because our job now is just to build an image, an OCI artifact, and push it somewhere. And then we have some sort of chain reaction that then triggers the in-cluster deployment. So what's really cool here is we still have our traditional kind of CI and delivery method. And then inside of each clusters, each of our environments, we can notice and detect these changes to the outside environment and bring them in. So we use an operator, and it's inside of our environment. So I really like this separation. And I'm assuming we're all here, we're probably looking at GitOps, and you're probably started using GitOps. So hopefully we're all on the right track. Now, a question that has been going around the GitOps community for a number of years now is, well, how do we handle multiple environments, and what does that look like? We don't all just ship every commit to prod. I mean, it would be nice if we did, but typically we want performance environments or QA. We want to make sure that we don't break things too quickly. And I love this issue. This is on the Flux repository. This is 2018. And it's one of the Flux maintainers from Weaveworks saying, hey, we should actually try and document this. And this issue has actually got a number of thumbs up, like 56. It's not huge, but there's interest here. People want to know, how do I do multiple environment GitOps? And what's really interesting, although it's not visible in a screenshot here, is people still comment on this issue, even though Flux v1 isn't really a thing anymore. So there's still a lot of confusion, concern, and questions about how do we do this right. So what do I mean by multiple environment? Quick image, I'm not going to go over this too much, but we don't ship to prod by default. We need to be able to promote and progress our code, at least in some environments. Financial regulations are much stricter. Startups, you maybe could just go straight to prod. Now, back to this issue. There was a follow-up comment from another Weaveworks engineer a few days later, and still in 2018, saying, I have created a repository which will house an example of how to do multi-environment GitOps. Anyone want to take a guess what's in this repository? Nothing. Now, I have spoken to Squaremo, the GitHub user here. There was good intentions. There are other branches that show a branching model for multi-environment GitOps, but at first sight, you look at this and you're like, oh, we don't actually have a good answer here, especially from the people that essentially coined the term and tried to promote GitOps in its early days. So what are our options when it comes to this? I only see 3 in the wild, and again, it comes down to the type of company that you are and what you're shipping, whether you're doing microservices and Kubernetes or not. But really popular one is the directory model, where we have one directory that describes an environment, and we have some concept of overlays to kind of augment or enrich the base layer. Another approach is the branching model. Every time we want a new environment, we create a new branch off of main. And while the repository one is not popular, again, in the financial industry, sometimes they need the constraints, and we'll talk about that in just a second. So with the repository approach, you get a really strong authentication boundary. You can actually restrict access to the entire production repository, maybe keep it to automation only, or maybe to 1 or 2 people that have the keys to the kingdom. Again, this is banks that I see going down this approach, where they really need to have strict concerns. But the challenge with the repository approach is drift, especially as your number of environments grow. Being able to syndicate and replicate all of these changes to all of the environments is really painful, to be honest. It's not something I would encourage anybody to try, unless you're forced to. Now, the branching model I like. We can promote through a pull request, which is quite nice, assuming we apply the log demeter to our GitOps pipelines. But it can be difficult to automate that promotion unless, it depends where you fall on that line. There seems to be people that are okay with machines pushing commits to the repository, and then there are people that are just, I'm never going to have a machine push a commit to the repository unless it's only machines that push commits to the repository, and so on. So it's really a trade-off in personal style. And drift still can be an issue. While we can define workflows and how we expect things to be promoted from branch to branch, they're actually really difficult to enforce. So it's a good model, but it has its challenges. The directory approach is what we're all stuck with, I think. We can still do promotion via pull request, but we have to make the same change multiple times if the environments all need it, or I guess you can use the base. Again, it depends on how much your environments deviate, and that comes down to understanding all the variants within your pipeline. Existing tooling already does this. And unfortunately, with the directory approach, you don't really have an authentication boundary at all. Anybody can open a pull request change in any environment. Now, we can do things like restricting pull requests to have a certain number of approvers before we merge it. But again, in some environments, it's not a strong enough or strict enough authentication boundary. So which one should we pick? Well, looking around, I only see directories. Every single tool out there that is in the GitOps space has just kind of defaulted to this approach. Kustomize being, I think, one of the early ones that promoted this. But Helm also does this. I mean, I don't know how often you go to GitHub and search for helm-staging.yaml or helm-production.yaml. There are hundreds of thousands of people adopting that pattern and using a different values file for Helm. And there's a cool Python project called KAT, which also just kind of defaults to this approach. So all of the GitHub tools do it. I'm assuming most of the people in this room also probably do that. And hopefully, I can encourage people to reevaluate that decision. So let's not forget about the law of Demeter. What are the challenges with the law of Demeter and the directory approach to our GitOps? Well, depending on how much of a snob you are with OOP, like, we're not generally big fans of inheritance. Inheritance can cause a lot of problems at building maintainable, scalable software because there are leaky abstractions, usually. Composability is not ideal. This is why trait-based programming languages, such as Rust, and I think are getting very, very popular. Because it allows us to write code that is easier to test and easier to maintain. So generally, we want to avoid using inheritance and overlays in these pipelines. And the number one reason is just the coupling. Like, what I would really want to try and hit home here is that if you're running microservices and you're not in monorepo land, which I don't see a lot of that, but maybe you're lucky. If you have all of your microservices, like, something I try and promote is that your deployment manifest and logic should live next to the code that they deploy. Probably shouldn't be pushing all of these manifests into a single GitOps repository because we have a two-stage commit process. And I don't like that. So if we have microservices and we are hard coding all this environmental information and overlays into all of those microservices, it's a lot of work. You'll probably end up going down the path of having someone explicitly that handles the release logic and making all of these changes. So I'm not a big fan. And let's not forget 12-factor manifesto. Right? This is why we have containers these days. This is why, you know, the Heroku team came out with all these great rules about how we should run applications. Right? We want to build a single image for our application and ship it to all environments, but then we have all of this environmental knowledge encoded into the deployment pipeline. Like, how did we take that step? I'm not entirely sure. So if we're building one image, we want one description of how do I deploy my application. And there are a few quirks to make this work, but again, I'm going to try and cover this today. So here's my solution. We want one description, that's why I call it canonical GitOps, but again, maybe I'll change the name, of how to deploy our application. It should live next to each of your services. So inside of every service, have a deploy directory. I mean, this is quite common in the Go world, at least anyway. So we should see that spreading out across more runtimes and languages. And we have to have a very strict separation of concerns between what is platform and what is application. We're very lucky that in this day and age, we're seeing a really lot of momentum and push for platform engineering. And I think that's fantastic because our platform team create the environments. So what if we could have a shared contract with them that we need the environment to produce a certain amount of information for our application to be able to run in the environment? That may sound familiar as part of the 12-factor manifesto. Right? We build an image and the environment produces everything that you need to run that application. So really, the only change you need to make to kind of have this approach to your pipeline is just define what that shared contract is. And the process for doing that is identifying all of the overlays that you have currently and having a list of invariants and variants and making sure that the contract is defined in order to do that. Now, when you're deploying to Kubernetes, and again, I'm just assuming that most people are these days, the things that need the shared contract are ingress. Right? We need to be able to specify the URLs that we're going to make available to each application from the platform. We also shouldn't really be setting replicas on our deployments. You know, we should use the HPAs as much as possible. Like, we want to define how our application scales across environments, and if we need to adjust the contract and say that the max replicas in dev is 2, then fine. But that's a shared contract between the platform and the application. Obviously, secrets can be a bit of a challenge, so you need to build that into your contract and have the platform provide access tokens to container registries, to databases, to cloud services, whatever you need, of course. If you're very lucky and you're in spiffy and Spireland, amazing. If you have workload identity in your cloud provider, great too. And there's more, but these are definitely the main ones I see people struggling with when I try and convince them or show them how can they do this in their application. These are the first things that they hit the wall. So what I'm going to show you is how I do this with Pulumi. Obviously, I work for Pulumi, but there's a couple of really cool things you can do here because Pulumi is code and it runs inside of my cluster. However, I have built proof of concepts that use Kyverno's mutating admission controllers to augment resources as they're going into the cluster. Prefixing domains within an ingress is all quite easy, swapping my min and max values. However, you're going to hit a certain level of frustration with the Kyverno approach, and then it may be that if you're not using Pulumi inside of your cluster, that just writing an operator that the platform team provides that handles the augmentation to your manifest as they hit the cluster will also work just as well. And I'm hoping this is going to work, but I really stupidly upgraded to the Mac beta recently. All right, so that is my application, and here's my platform. So I have two very distinct sets of responsibilities. I have my platform team that provides what I think is a nice interface, mainly because I built it. But the platform is a class or a function that returns an object that has methods that can be called on it. I can deploy an ingress component, and I've got nice enumerated types here that just tell it how to deploy contour to my cluster. I don't really need to specify how to do that. The code is smart enough to handle it for me. I add some common components that I like in my cluster. So if I want to deploy Cert Manager, it's one line. I use Red Panda quite a lot as a Kafka alternative. I'm deploying the Pulumi operator. And then we have the ability to onboard a team or a project or a microservice. So here I'm just saying, this application lives in this repository. This is all real code on GitHub. This is how I deploy my YouTube automation. So I have this Raw Code Academy, and inside of that there is a platform directory, which is the application side of the platform. I need to tell it which ingress control I'm using. And then this environment is actually my contract. And this is a really simple use case. The only thing, I don't need to scale my API. It's just for personal use. But I do need to make it available on a URL or a domain. So when I do deploy another environment, I can actually just swap out the domain I need. What's actually a much better approach is to randomize it as much as possible as well so that you can have ephemeral environments and then just have something push a GitHub comment. But that's slightly deeper down a rabbit hole. So that's the platform. That's what your platform engineers will do. You as a developer working on microservices can go to the platform and say, I want to onboard my project, and you specify the contract that you need. What's nice that I'm not really doing here is that this is TypeScript. This could be a really strict type where I define what I expect, and then parameters, what types are going to be, etc. So there's lots of things I could do to even improve this setup. This deploys the Pulumi Kubernetes operator to my cluster, which pulls that repository, monitors the directory, and runs the Pulumi program. So what does that look like? Well, this is how you work with Kubernetes and Pulumi. I've got some labels that I need to be kind of applied to everything. I then pull out the contract. Now in Kubernetes, it's just a config map. Of course, if I wanted it to be a secret, I can make it a secret. It depends what I'm stuffing into it. But then I have this variable called CM, where I can access all those fields that I expect to be there. Now, I have got a type here. I should probably make this shadable between the platform side and the application side, but again, it's my own infrastructure. Definitely room for improvement. But I have my API domain, and there's a few other things that I could be tweaking if I wanted. From there, this is just me deserializing that JSON blob that we get from the config map back into a TypeScript type so that I can reference the values. So you can see here, I add a new Kubernetes deployment. I create a service. Again, I'm using nice helper methods here to kind of not have to duplicate and write the same old YAML every single time. And then I have my ingress object, and the metadata and the FQDN are pulling from that shared contract that we have besides two teams. And that's it. the operator runs this Pulumi program. My application, the deployment logic is all defined once next to the code that it is running itself, and things are quite cool. Let's jump back over here. So you can do it with Kyverno. You could write your own controller. I'm just obviously slightly biased towards the Pulumi approach. There's some quick tips if you're going to do this. Really extracting the variance and invariance is the most important thing here. Understanding what changes between each environment and having that shared contract is critical. Randomize as much as possible. If you need secrets, use the operator that generates random values and secrets for you, or use the Pulumi or Terraform random providers. And get very comfortable always using an HPA, even in non-production-like environments, instead of just having certain scales set up front. So now, if I were to say which one or approach would we go, I would encourage you all to look at the branching model. Being able to promote via pull request is really cool. You have branch level protections on how we can merge stuff. There's no overlays and ephemeral environments, which are really important for me, at least anyway, being able to just, on every change, spin up a new cluster, deploy everything, and get a URL out, which I love. And we have absolute parity. The only thing that changes is the contract values. So that's me. Thank you very much for listening. I hope you found this useful. And if anyone has any questions, I'd be happy to answer. So thanks. Sorry, I know you all want to get to the live band karaoke. All right, well, thank you very much. Yeah, please.
So this is more of a meta question. Does it still count as GitOps if you're not actually committing which version you're going to deploy for a repository? You just have like a declared description of how the apps flow through environments?
Yeah, I've never really bought into that exactly redeployable thing. I mean, you could still do that. What I'm experimenting with right now is whenever I do a deployment with Pulumi, is actually to create an OCI artifact to push it to a registry to see that these were the contract values and all the containers that were deployed, et cetera, so that I still have a bill of materials, which is good for auditing and security. But for me, what's the most important part about GitOps is that constant reconciliation and inverting the control that is in the cluster. You know, I'm not leaking that environment information to build systems and workflows, et cetera. So I mean, I like that approach first, and then I'll work on the audit and security side. But yeah, there are a lot of people that are like, well, I should have a machine commit all the image SHAs, et cetera. But for me, it's more auditing that I need rather than being in Git. And I think the Flux project is actually doing this too. They've started moving away from having machine-generated commits in a project, and they're looking to push more things to OCI, as are Crossplane and other tools in this space. But good question. All right, go enjoy the karaoke. Thank you.